Okay, so we've got the machine set up. Everything looks good, so it's time to do a test. So I have Kavko Maker opened here. I've just set up a model really quick. The same size as my stock material. It's and I'll just show you that real quick. So when you first open the program and you start a new file, the first thing it wants to know is the size of your model or your material, the units you're working in, and where you want to position your origin. So for this, I'm going to set it right in the middle. I'm going to use inches, and it's 8 inches by 5 inches. So that's how I set it up. And then I just drew a basic rectangle with some text and programmed a profile toolpath. I've programmed to cut along the line. You can choose inside, outside, or along. So that's just going to follow this center line of those vectors with the center of the tool. My finish depth I have at 0.03. It's about a 32nd of an inch. My tool, if I select my tool from the pre-populated SaneSmart library, in here under engraving, there's a 20-degree engraving bit, which is what the machine comes with. So I've chosen that. And then if I expand that, I can set my feed rate and my plunge rate. And I think 20 millimeters per second for the feed rate and 10 millimeters per second for the plunge rate. We'll see how that does. Step over and step down. No need to worry about that for a toolpath like this. We don't need to worry about lead in or ramping moves. We're not cutting anything out, so we don't need bridges to hold it. We do want to set a safe Z height and a Z home. These are the retract heights. So when it's in a rapid motion, we want to make sure we retract far enough away from the surface of the material that we don't crash into anything. If you have clamps, take that into consideration and set this higher so that you clear the clamps. And then the last thing is just setting up the material. So I have the thickness set at 1/8 of an inch. My Z0 is at the top of the material. I've named it test, and I hit calculate, and that should be it. It will populate over here. Tells me the tool I'm using, and has my simulation ready. So if I right click, I can simulate my tool paths. This is what I get. So it looks good. You can also, if I reset this, let's delete it. If I click on the simulation control bar, this will let me actually preview exactly what's going to happen. So it looks good. And I did this just to save a little bit of time on the video. I didn't want to bore you with all the modeling and programming. Just thought I'd run through it quick. Once we're happy with it, let's reset that. Once we're happy with it, come down here, save toolpaths. Make sure your machine file format is set correctly. Like I said, I set it up and I'm using inches, so this is the UGS Gerbil inch format. If I expand this, you'll see there's also one for millimeters. There are a whole bunch of other ones in here, but UGS Gerbil inch is what I'm using. Pick your save to location, hit save. I'm not going to overwrite it right now. Okay, so next thing we do, I'll get out of this. Okay, so we've programmed our file. So next we need to send it to the machine. Set up the machine. So open Candle. I already have this set up, but if you need to set it up under service and settings, this is where you set up your connection and user controls. This is where you put your probe command. So set everything up in there. So I've opened it up. I'm connected. As we can see, the machine's idle. There are no alarms, so that's good. Over here we have the lock and unlock and reset. When the machine does alarm out, it will go into an alarm status, and I can demonstrate that if I hit the e-stop, which is so as soon as I hit the e-stop, now I have an alarm, and the machine's not going to do anything until I reset it. So to do that, I would unlock and reset. Simple enough. Okay, so let's find our G code. And there it is. All the code down here. Preview of what we've programmed. We're almost ready to send the G code to the machine and see if it cuts. But we want to set that up first so that it knows where it is in space and it knows where to cut and what to cut. So first thing to do is to home the machine. And what this will do is it will send it off in the 3 axes until it registers on the limit switches. This will let it know where it is and set the global coordinate systems to 0. So that's done. And we can verify that by looking up here at the top. Work coordinates is 0, machine coordinates is 0. So next thing we need to do is we need to set up our origin. So we'll use the jog controller for that. This y-axis is a little confusing with the control. Typically the gantry moves and not the table. With this machine, the table is moving, so when I jog in the y positive direction, the table is coming towards me. On most machines, when the gantry moves, Y positive, the gantry would move away. So basically doing the same thing, but it's just a little bit confusing, I think. I'm sure you get used to it. Or if you don't have anything to reference it against. But I digress. Let's continue setting this up. All right. So you might see on my workpiece there, I have I've marked out okay, a brief pause there because I ran into a small little issue. So because of the limited amount of Z-axis travel we have here, and the fact that I'm using such a short bit, the spindle has to come down quite far to reach the surface of the material. And what's happened is I've exceeded my travel limit and I've hit the limit switch. So I hadn't thought about that. It's not a big deal. It just means that it's something to be aware of, and to get around that, what I'm going to do is I'm going to loosen up the spindle and just lower it slightly in the holder so that it'll reach the surface of the material before it hits the stop. So I'll do that right now and then I will be right back. Okay, took me all of 15 seconds to do that. So what I did is just jogged up clear of the limit switch, loosened up the screw, dropped my tool down, dropped the spindle down until the tool touched the surface. So now I've got plenty of travel to cut. If you had a longer bit in there or thicker material, it's possible you run into the opposite problem and you hit the limit switch in the positive direction. Not really big issues, not for what we're doing right here. You can always move the spindle up and down in the holder slightly. Use shorter or longer tools to combat that. Just something to be aware of. All right, so with that done, let's continue setting up. Okay, so I've positioned the center of my tool roughly at my center point. I'm not too worried about it. I've got plenty of material there, so I'm not trying to squeeze this cut onto an exact piece of material. Depending on how accurate you're trying to be, you know, the more accurate your setup is, the more accurate your cut and material usage would be. But for this test, that'll be fine. So that's going to be my XY0 position. And I will set that in candle with this button right here. 0XY. And as soon as I click that, my work coordinates now read 0 and 0 in the X and Y position. Or I'm 0, 0, 1, but close enough. We still need to set the Z 0, and we will use the tool probe for that. So let's just jog the Z-axis up. Remembering not to go too far because we don't want to hit that upper limit and trigger an alarm. We just want to jog high enough to clear the probe. So I'm going to stick my probe under here. Attach the clip to the end mill or the engraving bit. It's kind of tricky doing all this holding my camera. with that set up, we will come back to candle. And this will be the Z probe command. All these buttons will tell you what they are if you just hover over them. So I've already set up the Z probe macro, and so it should be ready to go. Yep, so that did it. It just brought the tool down until it touched the pad and made a connection, and at that point it told Candle exactly where the surface was. Let's just move the probe out of the way. And so now we can see that Z position is reading 17.3. And that's because it's retracted away from the probe puck and it's off the surface. So we can verify if that's correct pretty easily by jogging the Z-axis down until this reads 0. At that point we should be touching the material. So let's Alright, so I've gone just below the surface according to Candle, and if we come over to the machine, the tip of my tool is just into the material, so that is set up correctly. If you want to jog in smaller increments, we can change that here. So this will be the step size of the manual jog. So if I wanted to get exactly to 0, I could do that. I'm at 0.203. So there you go, and right about there. So that's how you change the step size for the jog control. Let's keep it continuous. Continuous just means if I hold down my left mouse button, excuse me, if I hold down my left mouse button, it will continuously jog. All right, so we're ready to send the program. No need to get my tool back to 0, because it knows where it is, knows where it should be, it knows where it has to go. We can see on the preview screen here that this little target mark in orange is my tool position. This is obviously my origin. So let's send the program and see what happens. running and it looks like it's doing what we told it to do. That little spindle motor is a little bit noisy. Doesn't sound terrible though. The rest of the machine is smooth and quiet. And you can see it retracting there to the safe height that we set before it makes the rapid movement over to the start point of the next cut move. So what I'm going to do now is, this looks like it's going pretty well. So I'm going to override my feed rate a little bit and see if we can push it a little bit faster. So in candle over here, I can override. If I check this checkbox for feed rate, I can input a value here, a percentage, or I can just grab this slider and I can bring it up a bit. So let's go 120%. Pretty good. All right, there we have it. It's done. Watch your fingers on the bit if you're doing this. Just like we programmed.